right, so today we're going to talk about probably the most commonly used tool when trying to visually represent a quantitative distribution. That is the histogram. All right, very similar to the bar graph, but the bar graph is for categorical data. The histogram is for quantitative data. All right, so the definition that we're going to put down for this is a graph showing the distribution of a single quantitative variable across intervals. All right, and that is the key difference between this and the dot plot. All right, so a dot plot maintains values, and a histogram condenses them into intervals. And we'll take a look at that when we actually do an example. But that's sort of the main difference, is that a dot plot maintains the values. It maintains the individual values so that you can reconstruct the data set. A histogram condenses the individual values into intervals, so you kind of lose that information when you're looking at a histogram. So what are the steps to actually making one? You divide the range of data into classes or intervals of equal width. So generally you want at least 5 classes as sort of a minimum when you're making a histogram so that you can get a shape of the distribution. If you've only got like 1 or 2 bars, it's sort of hard to get a shape. So your classes should be small enough that you can get at least 5 bars out of them. Each value can only be in one class. So when you're labeling your classes, you wouldn't want to label them 0 to 5, 5 to 10, because then you're leaving it up to the reader to figure out, well, does this interval contain the 5s, or does this interval contain the 5s? Like, how am I supposed to read that? A better way of doing it is writing them like this: 0 to less than 5, 5 to less than 10. That way, there's no sort of ambiguity about what value is falling into which bar. Now, this is the default. Like, this is generally what you would expect it to be. So if somebody's not labeling it or making it clear, this is sort of how you should default to read it. So let's say this is the default, but it's always nice to not leave your reader guessing. And if they don't know that this is the default, they might interpret it incorrectly. All right, so you divide the data into classes. You find the count, so frequency, like how many observations fall into each class, or you can find out what % of observations fall into each class. So if your data was going from like 0 to 20, like, oh, I had 3 observations that were 0 to 5. I had 6 observations that were between 5 and 10. I had, let me use the better ones here. I had, 10 observations that were from 10 to less than 15, and so on and so forth. But you're counting how many of your observations actually fall into each interval. Then you label and scale your axes and draw the histogram. So vertical axis counts or percents. This is what kids sometimes mess up, is they try to put like some unit or something on the vertical axis, and the vertical axis is really just a count of how many observations fell into that category. The vertical axis could also be percentages, but like what % fell in a specific interval. The horizontal axis is where you're actually talking about the variable being displayed. All right, so this is the one that comes up a lot, is this is not a bar graph. You don't have spaces between the classes. So That's usually the big difference that kids remember, or they get confused on, like which one has spaces, which one doesn't have spaces. The histogram does not have spaces. An empty space should represent an empty class. So the only way there should be a space between the bar is if there's actually 0 observations inside of one of your intervals. So this is just like an example graph, and it's saying like percent of foreign-born residents for like each state. So this is saying 20. There are 20 states where their population is between 0 and less than 5% of foreign-born residents. There are like 12 or 13 states that have between 5 and less than 10% foreign-born residents. There's another, let's say, 9 states that have from 10 to less than 15%, and then so on and so forth. There might be like about 5 states that have from 15 to less than 20, but these bars should add to your sample size. All right, because for each observation, you're putting them into one of these intervals, either 0 to 5, 5 to 10, 10 to 15, and every one of your observations should be accounted for. So since these bars are just telling you how many are in each interval, if you were to add these bars together, it should add to whatever your sample size is. All right, and this is just the frequency histogram where we're counting. Over here is the relative frequency, which is instead of counting, we're doing it by percent. So you'll notice from 0 to 5, it's 40%. Right, 40% corresponds to the 20 that we saw over here, because there's 50 states and 20 out of 50 is going to be 40%. So in this case, it's the same idea, only instead of counting, you're doing it as percentages. So here your bars should add to 100%. All right, so again, this is saying that, we have our 50 states, 40% of those states are between 0 and 5%, 26% of those states are between 5 and 10, and then so on and so forth. So you can either do a regular frequency histogram where you're counting how many observations are in each interval, or you can be doing a relative frequency histogram where you're seeing what percent are in each interval. So just a quick note, these are the same graph. The only difference is their vertical scale. Right? One is counting the observations, and one is treating those observations as a percent. So like what percent of your sample is in each category. All right, so that's sort of the breakdown of what you need to do. Now let's actually do some examples so that you can see how this all works and sort of fits together. So, working for a living. How long do people travel to get to work? The following table gives the average travel times to work in minutes for workers in all 50 states and the District of Columbia. So we've got all 50 states and the District of Columbia. So we have 51 data points. So that means whatever our histogram ends up looking like, those bars should add up to 51, right? Because we have to account for every observation. We can see that the smallest observation, if you scan through, is 15.9. And the largest observation is 30.9. All right, so that's our smallest observation, and that's our largest observation. So when we're coming up with our intervals, we know that we should probably start at about 15, and then we can stop once we get above like 30. All right, so what I'm going to do is over here, I'm going to make basically like baskets, and I'm going to say, all right, here is my 15 to less than 18 basket because I'm going to do them as groups of 3. And then I'm going to go, all right, here's my 18 to less than 21. Here's my 21 to less than 24. Here's my 24 to less than 27. Here's my 27 to less than 30. And then here's my 30 to less than 33. All right? Because what I've got to start by doing is I've just got to count how many are in each interval, because that's the information I need to actually make my histogram. So I can go through these one by one and say, all right, 23.6. All right, well, 23.6 falls in this interval right here. 17.7, all right, that one falls in this one right here. 25.0, all right, that one would fall right here. And you would just keep going through. And I'm basically just doing tally marks. So let me finally get one more. So this one is also in here. So I'm just making tally marks to count how many are in each interval. All right, so I've got 2 there. I've got 1 there. I've got another one there. And I'm not going to lie, like, obviously this is a little tedious, but it doesn't take that long. All right, so you're just going through them one by one and just seeing where they fall. All right, so what I'm going to do is I'm going to pause the video and just finish this so that you can do it on your own and you don't have to sit here and watch me do it. Because if you can do it faster on your own, I don't want you to sit here like watching me. So I'm going to pause this and then I'll come back with the results. All right, so here are the final results. There were 6 observations between 15 and less than 18. There were 8 observations from 18 to less than 21. There were 16 observations from 21 to less than 24. There were 15 observations from 24 to less than 27. There were 4 observations from 27 to less than 30. And there were 2 observations from 30 to less than 33. If you got slightly different answers, it might just be that you messed one out the little way. Make sure that this 24.0 you placed here and not here. This is less than 24, so 24.0 would end in this basket right here. But these numbers right here, these numbers, the count of the observation, these are the heights of your bars. All right, so when we actually make our histogram, right, I know that my vertical scale is going to have to go up to at least 16. So I'm going to go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, and there's 0. Again, I start my scale at 0. I don't start it at 2 because I want the area to reflect what's going on here. So, you know, my scale is starting at 0, so I'm getting the full range there. Now, my intervals, I don't need to start my intervals at 0, all right, because I'm not losing any information by starting my interval. I can go 15, and then to make it a little more clear, I'm going to go 15 to less than 18, and I'm going to draw a little less than sign there so that somebody that's looking at my graph kind of knows that it goes from 15 to less than 18, from 18 to less than 21, to less than 24, to less than 27, to less than 30, and then finally less than 33. All right. And at this point, all the hard work has been done. Now you're just like, all right, well, this first block has to be 6 high. So let me do that. This next block has to be 8 high. So let me do that. And again, I've got no spaces in between here. This next one is going to be 16 high. So that goes all the way up here. And again, I'm not using a ruler here. I'm not expecting you to use a ruler. As long as everything sort of matches up with where it should be and it's not like grossly off. That's all I'm looking for on something like this. The next one is 4. So that brings us way back down here. And then the last one is 2. Okay. So we've got, a fairly symmetric distribution, not perfectly symmetric, but rarely are they, where you've got sort of this big peak in the middle and then it tails off pretty quickly to both sides on the left and to the right. Obviously, there's a little more on the left than there is on the right. But, for the most part, it's relatively balanced. All right. So that would be how you do just a normal frequency histogram. And then again, you should label it. So this side, again, is just the count. All right, it's just counting how many there are. And this side would be the average travel times. And again, this is what we call the frequency histogram. All right, so that's sort of the process of making a histogram. Now, if I were to give one on a quiz or a test, I'm not going to give you 50 observations. I did that for this first one just to kind of drive home what we were actually doing, the process of counting all of those up and making sure you understood that that's what the histogram is. But on a quiz or a test, it's probably more going to be in the neighborhood of like 15 observations or something like that. It's not going to be 50 of them. All right, so right here, this would be your frequency histogram. Now, if I wanted to make this a relative frequency histogram, what I would have had to do is put all of those over 51. So I would have done 6 over 51, 8 over 51, 16 over 51, because I have 51 observations. These would all give me percentages, something percent, something percent, something percent. And then those percentages would have been the heights of my bars. So that would have been the difference between a frequency and a relative frequency histogram. All right. But that's sort of one take on it. Now, let's see another way that your data could be presented. All right. So we have the second one here that says, have you ever seen the rain? The data below refers to the number of days with rain in 1,000 cities across the globe over a 30-day period. All right, sketch a relative frequency histogram to summarize the data above. What are you using as your bin width? Once you have the histogram, describe the distribution, shape, spread, and center. So this data is being presented a little differently, but what this is saying is that out of the 1,000 cities, 3.6% of them only had 1 day of rain. Of the 1,000 cities, 14.8% had 2 days of rain. And then if we go all the way to the other end of this, out of the 1,000 cities, only 0.2% had 15 days of rain. Okay, so what we can do here is, again, we're going to divide this up into intervals. All right, so we have 15 different kind of data values here. So it might make sense to just, again, it's not always going to be 3, but like break each of these into a group of 3. So here's one group. Here's a second group. Here's a third group. Here's a fourth group. Here's a fifth group. So we still have the 5-bar minimum that we're generally looking for when we make a histogram. Now this one's actually a lot easier because they already give us the percents. We're just going to have to add these percentages together. So I'm going to make the same baskets that I made before. There's my 1 to 3. There's my 4 to 6. There's my 7 to 9, 10 to 12, 13 to 15. But instead of making tally marks, I'm just adding these together. So this one would be the 3.6 plus the 14.8 plus the 18.7. That's giving me the combined percentage that was between 1, 2, and 3. All right. Same here. This one would be 16.0 plus the 12.5 plus the 8.2. This one would be the 8.1 plus the 5.9 plus the 4.4. This one would be the 3.6 plus the 2.1 plus the 0.9. And this one would be the 0.6 plus the 0.4 plus the 0.2. All right. And again, you don't have to draw these baskets out when you're doing it. I just like it as sort of a visual representation of what you're doing. So you're combining those together to sort of get the end result. So this one would be altogether 1.2%. This one would be 5.7. So this would be 8.6. Wait, not 8.6. If I do 5.7 plus 0.9, that's 6.6%. All right, so 1.2, 6.6. This one's going to be 6 is 14 is 18.4%. This one's going to be 28 and a half, 36 and a half, 36.7%. And then this last one is going to be 14 plus 18 is 32, 33 and a half, 36 and a half, 37.1%. And again, if you want to make sure that you didn't goof anything up there, those should all add to 100% because we're accounting for all the observations. So 37.1 plus 36.7 plus 18.4 plus 6.6 plus 1.2 gives me 100. So that, again, tells me that I did that correctly. And again, these numbers are the heights of your bars. So if I'm making my scale, right, this time the vertical scale, instead of being counts, are going to be percents. And I know that I need to go up to about 37%. So I'm going to start here at 0%, and I'll go up by 5. So there's 5%, 10%, 15%, 20%, 25%. There's 30%. There's 35%. There's 40%. All right. And then down at the bottom here, to represent my intervals, I'm going to say, all right, here's 1, and then I'm going to go to less than 4. All right, so if I go from 1 to less than 4, I know that this first bar is going to have the 1, 2, and 3 that I want it to have. And then I'll go to less than 7, so that I know this bar is 4, 5, and 6. Less than 10, 7, 8, and 9. Less than 13, 10, 11, 12. And then less than 16, so that I know that this is 13, 14, and 15. All right. So once I have that, I can draw my bars. So this first one is 37.1%. So I'm going to say that that's about there. And again, this is where, again, I'm not going to be looking for exact perfection as long as it's in the ballpark. So this next bar should just be ever so slightly smaller than the last one, but obviously not by a whole lot. And then this one should be quite a bit smaller. It's going to almost be half the size. So we'll make that one there. And then 6.6, we're getting smaller still. So we'll make that approximately right about there. And then this last one at 1.2. All right. So there's my histogram. Again, let me label this. So this is number of days with rain. This is a relative frequency histogram because it's using percentages. And again, those bars are going to add up to 100% because we're accounting for all possibilities. And then last but not least, if we're going to describe the shape, this would definitely be right skewed. All right, so the shape is right skewed because we've got a tail off to the right. All right, our measure of center, we'll do center next. All right, when something is right skewed, you should be using the median. Now, how do we find the median? The median's the halfway point. So the halfway point is 50%. So if we start adding these together, we know the first three add up to 37.1%. So if we go to this next one, which is 4 days of rain, all right, 37.1 plus 16 is, so how do I want to do this? All right, so I'm going to write here is the 50% point, all right, because I want to just show the work of how I'm doing this. So 1 day was 3.6. So 2 days was 3.6 plus the 14.8. 3 days was plus the 18.7. 4 days was plus the 16.0. Right? And when we add those together, that gets us to 37.1 plus 16.0 is 53.1%, right? Which means the halfway point fell in this category right here. All right, so the 50% point would be 4 days. All right, so sometimes kids try to use these numbers as the median. These numbers down here are not your data. It's telling you what percent of your data had this observation. What percent of your data had this observation? So when we're calculating the median, it's going to be one of these numbers up here. And we're using these percentages to figure out where that 50% mark falls. And it would fall right here on day 4. And then the same thing, if you're calculating the spread, so far we're just doing spread as range. Again, max minus min is not looking at these percentages. All right, these percentages do not represent our data. Our smallest data value is a 1. Our largest data value is a 15. So our spread would be 15 minus 1, or put another way, 14. All right, and that's where kids usually get goofed up, is they start using this as their data when in fact your data is the 1 through 15. This is just telling you how often that result occurred from your 1,000 cities. All right, so I hope this was helpful. I would say that this is the one that the kids sort of goof up the most because they start to confuse these two different rows and what those are actually telling you. But you just have to remember that the percentages are not the data. All right, the percentages are just how often the data occurs. This right here is your actual data. And again, that comes from reading the problem and making sure you understand what the table is actually trying to tell you. All right, so that is it for today. I hope these were helpful, and I will see you when I see you. Bye.